Welcome back. Today we're going to talk about solving linear inequalities. So last video lesson we talked about just representing inequalities and being able to graph them on a number line. Today we're going to be solving linear inequalities, very similar to solving equations. So let's jump right into it. All right, let's take a look at our first example. What I want to be able to do in each of these is solve and graph. So let's take a look at our first one here. Example 1, we have 8 is less than or equal to x minus 2.5. So again, what I want to know is what value or values of x would satisfy this inequality. But we, unlike what we did in last lesson, is that x is not by itself. It is with minus 2.5. So just like we would in equation, what I want to do is I want to solve for x. I want to get x by itself. So what we're going to have to do here is our old inverse operations in terms of solving for x. So if I have minus 2.5, if I want to get x by itself, what I want to do is just add 2.5 to the other side. I'm going to add 2.5 here to 8. And that's going to tell me 8 plus 2.5 is 10.5 is less than or equal to x. So basically this is telling me that 10.5 is going to be less than or equal to x. So what I want to do is represent this solution on a number line. Now remember, since we have the number first, again, I always like to read this with the variable first, so let me just quickly rewrite this. Okay, I'm going to flip my x and bring this on the left. Notice how the opening is pointing towards x, so I'm just going to flip the inequality here. What does that tell me? It's just easier to read, I guess, and easier to understand in graphing. X is greater than or equal to 10.5. So putting this on a number line, I kind of have this set up for you guys as well. Here's 10, 11, 12, so I'm going to put two numbers bigger, put 9 and 8 there, and then notice here how I have right between 9 and 10. It's not there goofy, it's just there on purpose. That's going to be 10.5. So to again represent this on a number line, I am going to put my dot at 10.5. Since we are including it, the equals sign is with that. We are going to close it, and then I want any value that's greater than 10.5, so that's going to be to the right. All right, now the next thing I want you to do to understand this is I want you to check your solution. So what we have here, instead of a single value, we're saying that anything 10.5 and above is going to satisfy this. Now to show you, I'm going to take and choose a value that's in this range. Okay, if I say that 10.5 or above satisfies this inequality, let's pick a number, like 12. Now what I want you to do when I say check the solution is take 12 and plug it back in. So if my inequality started off 8 is less than or equal to x minus 2.5. Well, let's take and plug 12 in for x. So I'm going to have 8 is less than or equal to 12 minus 2.5. So that's going to be 8 is less than or equal to 12 minus 2.5 is going to be 9.5. Okay, so if we check that answer, is 8 less than or equal to 9.5? It's certainly less than, so it satisfies this inequality. Okay, so therefore, if it satisfies inequality, makes it true, check, that is a solution that works. All right, example 2, same kind of problem here. Now we're just going to solve for g. So as g plus 4.2, so to get g by itself, I'm going to subtract 4.2 from that side, bring it over here. That's going to leave me with g on this side is less than 1.4. Okay, so 1.4. Again, just throwing some decimals in here, that's okay. I have it here again set up for you. This line is going to represent 1.4. So what numbers will we have on the outside of it? Well, we're going to have 1 here, 2, and then I'm going to pick 3 and 4, two numbers above 2, and go down to 0. Okay, now this one says g is less than 1.4, so I'm going to again put my dot or my boundary at 1.4. I'm going to leave it open this time because we were just talking about less than. We are not including 1.4, and therefore I'm going to draw an arrow to any value that's less than that. And again, a helpful thing to do here is check your solution. So let's pick a number that we can plug in to this inequality and see if it works out. So I'm going to plug in 0. Let's say g was equal to 0. Okay, so if g is equal to 0, we're going to plug it into our original equation here. So 0 plus 4.2, is that less than 5.6? So 0 plus 4.2 is simply 4.2. Is that less than 5.6? You betcha it is, so that one checks out. That one's perfect. So very good. All right, now from here then, let's take a look at example 3. So same idea here. 4h greater than negative 16, so this one I want to solve for h again. This one we have 4h, so what am I doing here again? I want to divide by 4 because that represents multiplication. So 4 is going to cancel out, divide the other side by, oopsies, not negative 4, by 4. And that's going to give me h is greater than negative 4. So plugging in my number line, let me just put negative 4 here. Careful again when you're graphing the negatives. Remember, negative 3, negative 2, then negative 5, negative 6. You know, if I skipped a line there, I'm sorry about that. So I can go negative 5, negative 6, and I got an extra line, so I might as well just throw negative 7 on there too. Okay, so now when graphing this, I'm going to put my boundary at negative 4. Then I want to know every value that's greater than negative 4. So greater than is always going to go to the right in this case, and therefore we're saying any value in that direction is going to be greater than negative 4. To check our answer, let's choose a value. Let's choose negative 2, and let's plug it into our original equation. So I have 4 times h. So instead of h, I'm going to plug in negative 2. Is that greater than negative 16? So you get negative 8 greater than negative 16. You may look at this and say, there is no way 8 is greater than negative 16. But remember, negative 8 is less, I shouldn't say less negative, well, I guess that makes sense, is not as negative as negative 16. So this actually does check out. That does work. So when you remember with the inequalities and the negatives, you got to remember something that's less negative, a smaller number in the negative is actually a bigger value. All right, and lastly, let's take a look at example 4. We have 2 is greater than or equal to r over 5. So when I write, remember, like this, r over 5, what does that mean mathematically? This represents division. So to cancel that out, I need to multiply. So in this case, I'm going to multiply this side by 5, and I'm going to multiply this side by 5. That's going to simplify to 5 times 2 is 10, is greater than or equal to r. Okay. Now remember, I like to write this. If you understand these inequalities, you don't really need to do this, but I like to write the r first. So I have r is going to be, notice how the arrowhead points towards r. So just flipping this is going to be less than or equal to 10. Remember, if 10 is greater than or equal to r, then r is less than or equal to 10. So then I'm going to put 10 here. I'll choose two values above, 11 and 12, and then we'll go 9, 8, 7. Put my boundary at 10. Okay, I'm going to close it because it says less than or equal to, and then I'm going to use my arrow to represent anything less than, which would be then to the left. Okay, then let's choose again, check our solution by choosing a value. Let's just punch in 7. Okay, so if I punch this in, 2 is greater than or equal to 7 over 5. All right. All right, now some of you might be freaking out here about 7 over 5. I can't do this. Well, remember, a fraction is just division. Remember I said I'm dividing by 5 here. So let's take and divide this out. I'm going to get 2 is greater than or equal to 7 divided by 5 is 1.4. So is 2 greater than or equal to 1.4? It's certainly greater than, so this checks out. So again, with checking our solution, it's certainly okay to divide those two numbers to get a decimal. Okay, a couple more examples here. Again, we're going to solve and graph each solution, and then we're going to check our answers. So this one, we have negative 7h is greater than 42. So again, if I want to solve here for h, what I'm going to do is take and divide by negative 7. Divide by negative 7. That's going to give me h is greater than negative 6, right? 42 divided by negative 7 is negative 6. Okay, so now I want to graph these, so I'm going to place negative 6 in the middle. Again, careful with the negatives. I'm going to put negative 5, negative 4. Remember, those are actually bigger values than negative 7 and negative 8 over there. Okay, got to make sure you do this correctly. Then, placing my boundary at negative 6, I'm going to leave this open again because it's simply greater than, and I'm going to represent any value that's greater than negative 6. Now here's where checking your solution is important. I'm again going to choose a value that's greater than negative 6 and say negative 4. And I'm going to take and plug this in to my equation. So my equation is negative 7h greater than 42, so I'm going to write negative 7 times negative 4 instead of h, plug in the negative 4, is that greater than 42? So negative 7 times negative 4, this gives you positive 28. Is that greater than 42? Well, think about it. 28 is not greater than 42. So this does not work. Meaning, when I graph this, these solutions are not right. Negative 4 doesn't work. Well, if negative 4 doesn't work, negative 5 doesn't work. Okay? Well, let's try something. What about if these solutions don't work, what about the other two? So let's choose, for example, negative 7. Let's see if this one works. So if I type this or plug this in, negative 7 times, and now for h I'm going to plug in the other side, negative 7, is that greater than 42? Well, negative 7 times negative 7 is positive 49. Is 49 greater than 42? And yes, that checks out. So in terms of my solution, okay, I need to kind of cross this side out. That arrow doesn't work, but instead I should have my boundary still negative 6, but what we found is that negative 7, the numbers that are actually less than negative 6, ended up working out. So my original answer of h is greater than negative 6 didn't work out. What we found is that h must be less than negative 6. Okay? So what ended up happening? Well, my symbol that was now greater than then turned into less than. Interesting. Okay, let's take a look at another example here. Example 6. I have 3 is greater than or equal to negative r over 15. So again, I want to get r by itself, so I'm going to multiply by 15. That's going to cancel this out. Multiply the other side by 15. 3 times 15 is 45. Is that greater than or equal to negative r? Okay, now this one I have negative r. Remember, we want r completely by itself. Remember, when you see a negative, that's negative 1r. So to get rid of that, I'm going to divide by negative 1. And I'm going to get negative 45 is greater than or equal to r. Again, I like to rewrite this, so that's going to tell me that r is going to be less than or equal to negative 45. So again, if I plug this in, let's just put negative 45 here. I'm going to choose two values above it, so negative 44. Careful again with the negatives. Negative 43. Then we'll go negative 46, negative 47, and negative 48. All right, so graphing this, I'm going to put a closed dot at negative 45 and represent any value that's less than. That would be going to the left. Again, to show you, let's check our work by plugging in a solution here. So I'm going to plug in negative 48. So I have 3 is greater than or equal to negative, careful here, negative 48 over 15. Why do I have to be careful with the negatives? Because notice here I have a negative. Negative, what's going to happen with these two? They're going to turn into a positive. So I'm going to have 3 is greater than or equal to 48 over 15. To help you out here, let's just take and plug 48 over 15 into a calculator, and let's see what we get. Plugging that in, you should get 3.2. So is 3 greater than or equal to 3.2? No, it's not. 3.2 is greater than 3, so this inequality does not work again. We have to flip the sign. 3 is actually less than or equal to 3.2, not greater than or equal to. So this would tell me all the way back here with this one that r is going to be less than or equal to negative 45. I'm sorry. What I need to write here is that this value of r needs to be greater than or equal to negative 45. On my graph, that would mean these values don't work, but they must be the other values. Just to show you again, let's plug in negative 43. If I take 3 is greater than negative 43 over 15, let's see what happens here. Again, this is going to form a positive. 3 is greater than or equal to, and I'm going to plug in, sorry, that's a greater than symbol, 43 divided by 40 or 15 into my calculator. And that's going to give me about 2.9. Now, if you look at this one, 3 is definitely bigger than 2.9. So this works out. So what ends up happening here is that r must be greater than or equal to negative 45 and not the original solution that I got. So what do we notice here? In both these examples, I had to divide by a negative or even multiply by a negative. And what ends up happening? When I multiply, divide by a negative, the sign flips. The inequality reverses. And this is going to be one of the rules that you guys are going to need to understand. Anytime you are solving an inequality, anytime you have to multiply or divide by a negative number, you must reverse or flip the sign of the inequality. Why? Because when you are dividing by a negative or multiplying by a negative, you are changing the value of the other side. Okay? Just for example, if I take 2 is less than 3, if I all of a sudden multiply both of these by -1, I'm going to get -2 is less than -3. Well, what we found is that this is not true. -2 is actually greater than -3. Okay? So this is true, not this. So just by multiplying or dividing by a negative, the sign must flip in order for the inequality to be true. Okay, so this is one rule you're going to need to write down and need to understand when you see problems with inequalities. All right, last two examples in here. We're going to take these verbal phrases, write them as an inequality, then solve in graphs. So first of all, we have the quotient of y in -3 is greater than or equal to 12. So do this. We're going to start left to right. We're going to start with the quotient. Quotient means division of what? Of y in -3. So I'm going to take y and divide it by -3. And it says is greater than or equal to. So that would be greater than or equal to like that. 12 would then be my answer. Okay, so now I wrote my inequality. Now let's go ahead and solve and graph it. So to solve, if I'm dividing by -3 to get y by itself, and to multiply by -3, and multiply this side by -3, that's going to give me then y is, whoa, hopefully you caught yourself there, because what did I just do? I multiplied by a negative. So what we just talked about, anytime you see this, flip the sign. It's not greater than or equal to anymore, but less than or equal to. 12 times -3 is -36. So now to represent this solution, I put -36 in the middle. Choose two values above, so -35 and -34. Again with the negatives. Again, careful. Don't know how many times I've said that today. Then I got -37, -38. I know I got an extra line in there, but that's okay. To represent then the solution, I'm going to put a closed dot at my boundary of -36, and I want to represent anything less than, so that's going to go towards the more negative numbers to the left. Okay, so again, careful with that negative sign. Last one, the difference of b and 12 is less than 5. So difference, what does this one mean? Difference means subtraction. So of b and 12, so I'm going to take b minus 12 is less than -5. Okay, now I have b minus 12, so to get b by itself, I'm going to add 12 to the other side. Now with addition, I don't have to flip the signs, only with multiplying and dividing. So -5 plus 12 is going to tell me b is going to be less than 7. Represent this on our number line. I have 7 in the middle. Choose two numbers below, 8 and 9. Then I'll 6, 5, and 4. That's an ugly 6 there. Oh boy. Okay, open dot at 7. That's my boundary. It's only less than, not equal to. So less than 7, I'm going to go with an arrow to the left to represent anything that would be less than 7. Very good. Okay, now I want you to go ahead and pause the video here and try these last two. Okay, so I want you to solve these inequalities and then graph your solutions on the number line. So give it a pause. Here we go. All right, let's take a look. Here we go. The answer should have just popped up. First one I had to divide by -6. So -12 divided by -6 is 2. That's going to leave me with just h. But, again, I have the arrow pointing to it because I divided by a negative number. I had to flip the sign from greater than to less than. So therefore I have 2 is less than h, which again I like to write from left to right. So h is greater than 2. So graphing that, since my boundary is at 2, since it's not equal to, it's just greater than, it's an open dot, and I'm representing anything greater, which would be to the right. Next example here, I have -12 plus h is less than or equal to 8. So I had to add 12 to get h by itself to both sides. I don't have to worry about the negatives because we're adding, not multiplying or dividing. So I'm going to have h is less than or equal to 8 plus 12 is 20. Wrote my numbers on a number line, closed dot because it's less than or equal to, and because of the less than, I'm representing with an arrow any number less than 20. All right, again, if you have any questions, kiddies, make sure you write them down. Otherwise, I will see you in class. Good luck on the practice problems and the mastery check. Peace out. Big Dog's out of here.